name is Jecton Anyango. I'm a PhD student at the University of Cape Town, and my supervisor is Professor Hussein Suleiman. The topic for this project is an investigation of a game generator tool to teach recursion. Imagine you are a lecturer at the university or any higher education, and you meet these novice students who don't have background or have got limited background in programming, and you are to teach them the topic of recursion. It has been shown that learning programming is difficult for most students, but particularly the topic of recursion has proved to be more difficult. Although games have been proposed as an alternative instructional media, given their motivational impact, their mainstream adoption rate in teaching still remains low. One reason which has been given for this is the fact that designing and developing relevant educational games is difficult, expensive, and time-consuming. In this project, a game generator tool is proposed to support non-technical experts or teachers who don't have game programming skills to easily create games so that they can be able to adopt them to support them in teaching some of these abstract concepts in programming. The results of this project suggest that the proposed tool is effective in supporting Computer Science 1 teachers and that the generated games have the potential to support or to help students to better understand the topic of recursion. The objective of this project is therefore to investigate the effectiveness of using a game generator tool to automatically create game instances to teach the recursion topic. We have two research questions. 1. What conceptual attributes must the game generator tool take into account in order to generate a game that can teach the topic of recursion? Number 2. How effective is the use of a game generator tool in creating customized games instances to teach the topic of recursion? To be able to accomplish these two objectives, the methodology we adopted was user-centered design approach. We developed a game generator tool, prototype. This was followed by user evaluations with introductory programming teachers and students drawn from Kenya and South Africa. 4 experiments were conducted. 2 online experiments with Computer Science 1 teachers, a control lab experiment with Computer Science 1 trainee teachers, and an online evaluation with introductory programming students. The results. Experiment 1 and Experiment 2 was conducted with Computer Science 1 teachers to find out the usability of the prototype which we developed, and also to find out their view of the potential of the proposed tool to support non-technical programming teachers. The results suggest that the tool has the potential to support non-technical teachers to easily create programming games. So this solves the barrier of lack of the technical skills to be able to create games for teachers who may want to adopt game-based learning. As we can be able to see in this graph, on the usefulness, the teachers reported that the tool would be more effective. A majority of them strongly agreed that the tool would make their work to be more productive, that the tool would be useful in creating Computer Science 1 games. The tool would give them more control, and then it would make the things which they want to get done easier, and the tool would actually save them on time. So this was going to solve one of the identified problems, that is teachers who might want to use game-based learning but find it difficult to be able to do that because they lack tools which can enable them to easily create customizable tools. So 87% expressed that the tool was useful after using it to create some games. that it is easy to use and to learn. 80% of the respondents expressed that view. Experiment 3 was conducted with trainee teachers drawn from Kenya, and we used the attractive questionnaire to be able to understand what the students' perspective were on the pragmatic uh, value, the hedonic quality, identity, the hedonic quantity, stimulation, as well as the attraction. The students use the tool to create some games, and then on average we can be able to see that on the two games which were created, the D&D and the mushroom picker game, the scores on a scale of -3 to +3 being the best evaluated, they said that they had the better usability with the tool, the pragmatic view. And then hedonic quality identity, we can also see that the average for the two games were above 0, as well as the hedonic quality stimulation, as well as the attractiveness. So on this evaluation, the results suggest that the trainee teachers found the tools to be more appealing, and they reported that they were useful. The tool was useful to enable them to create games which can be able to use to teach programming. Let's take note that these are potential users of this tool. They are potential adopters of this technology, of this proposed tool, because they still don't have experience in programming. And as we can be able to see from the results, they expressed that the tool would be useful for them. Furthermore, they said that the generated games, they played them, and they said that they would be useful to learn the topic of recursion. The last experiment which we used to evaluate the developed prototype was with computer science 1 students. We wanted to get from the lens of the students what they thought about the generated games. So they played the generated games. This was an online experiment. And then after that, they filled the game experience questionnaire. The results suggest that the students had a positive experience with the played games, with a majority of them agreeing that the played games helped them to understand the topic of recursion better, and they actually proposed that such games should be adopted in learning the topic of recursion. So from the evaluation studies, we can be able to confirm that the game generator tool has got the potential of supporting teachers to be able to create games which can be able to teach recursion, and from the view of the students, that the generated games are deemed to be useful. And because of this revelation, we strongly argue that the proposed idea has got the potential of changing the way some of the abstract concepts in introductory programming are taught. Thank you for listening. If there's any question, you can be able to ask it so that I can be able to respond.